I guess mine is, if not the last, the second last talk. I guess we're all pretty tired, and everything's fine. So this is IoT-A. Basically, I'm the technical coordinator of this project. Now, because I'm the technical coordinator of this baby since 2 years, you can wake me up in the middle of the night and I can deliver this presentation in automatic. So I say this because in case I go too fast, too slow, I'm too boring, you don't understand, just raise your hand and I will tune the presentation. What is IoT-A? IoT-A is the flagship for Europe for IoT. IoT-A means IoT architectures. 18.6 million of budget, 12 of which are coming from public money. 17 partners from 8 countries. I am the technical coordinator. The project started in 2010 and is supposed to finish after 36 months. This we already spoke for the whole day. We all know that the current situation is basically intranet of things, not Internet of Things. They're vertical silos. We develop a RFID solution, we develop sensor solution, we develop actuator. There is very little interoperability and compatibility between solutions. Even within the partner of the project, I mean, it was a little bit tough at the beginning to understand what exactly we were doing. I mean, we're talking about narrow waist, AP level. People will say, oh, we just put something below the service layer and it's done. No. We cannot put something just below the service layer and the job is done. We came out then with this picture, you know, we say a picture is 1,000 words. And this picture just shows, I mean, what is the focus of IoT-A. We're not really working on specific technologies. Bluetooth is there and is there to stay. Zigbee is there and is there to stay. They have very powerful consortia behind it, very powerful alliances. We're not going to fight with them, even if the consortium of IoT-A is mainly composed by industry, big industry. 2/3 are actually coming from big industry, not SMEs. Those technologies, as I said, are there to stay. And there will be quite a lot of fields which will be impacted by Internet of Things, which are the leaves of the tree. So what IoT-A is trying to do is really to build a trunk, to make all these kind of technologies available for all these kind of fields and domains. A boring slide. I call it the boring slide, but it's necessary because, as I said, even within the consortium, there was not agreement of what a reference model was and what reference architecture was. You know, IoT-A is IoT architecture, and we soon figure out, I mean, even before the project was starting, that a single architecture for the Internet of Things does not make any sense. Simply because, I mean, Internet of Things is so wide and there is so many different domains and fields, and you span from applications which are for fun to applications which can save life. Are you using the same architecture for the 2 of them? You may say maybe. Take a car, even within a domain, you take a car, you take air conditioning of a car. If the air conditioning doesn't work, what do? You open the window. If the ABS of your car does not let your car brake, what are you doing? You crash into the wall. Two different systems, smart systems, which can be seen as IoT in the same object, and they have to have totally different architectures. So then, I mean, we figure out that the common level is the reference model, which is an abstract framework for understanding significant relationship. I'm reading because I don't know it by heart. And basically, this very abstract layer, which is basically how do 2 objects communicate? How do they speak to each other? You know, what is the commonality between things? This level of abstraction, I mean, enables the development of specific reference architectures. So reference architecture is just a design pattern. It's a blueprint that then can be used then to build a specific architecture. This is the architectural reference model that we're talking about. We started from business scenario and existing architecture, and this is mainly for several reasons. Reason number 1 is that we are very big industrial-based consortium. Industries don't want to throw away millions they already spent in development, so they want to reuse what they already did. Therefore, I mean, it was obvious it was an evolutionary approach and not a revolutionary approach. This made us understand a little bit of the whole domain for what we're talking about for IoT. So then we have a reference model there. You will see very quickly what the reference model will mean. That basically guides, as I say, drives, I mean, the reference architecture. Having business scenario, existing architecture, and stakeholders, we can have application-specific requirements. I can have IoT, can be retail, can be logistics, can be health, can be transportation, can be whatever, and sometimes those requirements are similar, sometimes are different. We went to the bother of extrapolating and to get some higher abstraction requirements, which we call unified requirements, that are used to build the reference architecture. At the end, the most important box is this one, the compliant domain-specific architecture. You can build an IoT architecture without IoT-A. People do that. But what is the advantages of using this one? Is that if you have your own application-specific requirements, and if you have what we will see, the cookbook, which is the reference architecture, you can build compliant domain-specific architecture without pain and without too much cost or without too much effort, hopefully. When we're talking about reference architecture, what comes to mind? I had some slides, because it's one of the last presentations, people are getting tired from it. I have to surprise a bit. This is the reference architecture from Le Corbusier. Okay, so this is the way that imagined Paris to be. Total separation between cars, people, shops, and living. Is this a nice town to live? I don't know. This is smart cities. That's a totally different topic. But this is what reference architecture for some people mean. In our field, hello? In our field, this is a reference architecture. This is what most technologists think that this is a reference architecture. There is a database, there are objects, blocks. One of the problems that we have in the Internet of Things is that because many of the technologies are coming from these areas, they tend to see that this one is the reference architecture we have to build. Problem is that Internet of Things touches totally different fields. I always say, okay, there is Internet and there's things, it's already an oxymoron. Internet is something virtual, does not exist. It's digital. Things is an object. That chair is a thing. That table is a thing. So we have Internet of Things, so something virtual made of something which is real. So already we have this oxymoron starting from, and we have to build kind of reference architecture for that. So these kind of blocks, although they are important, they cannot be the end of the journey for building a reference architecture for the Internet of Things. So, what we want to do at the end is the cookbook. Okay, this is a beautiful steak. Last night I had a beautiful one. By the way, I went to a place called BASSI, and I was told it was the best one in Sao Paulo for the meat, and I was brought there, and I really enjoyed the meat here. It's not my cousin, unfortunately. No relatives of it. My Brazilian relatives are coming from my mother's side, so not on my father's side. But anyway, this is the cookbook. So at the end of the day, what we want to build is a cookbook. There are some ingredients, there are some recipes, and there are some final results. And each one of any director of innovation of a company should be able to pick this cookbook and having the material that he has and that he wants to use with the price concerns, with time concerns and whatever, should be able to build a recipe, which is his own recipe. This is the architecture we're facing, totally heterogeneous. We have internet gateways, we have some connected objects. Here there is some ad hoc connection. Here we are something that are just connected because of proximity of a gateway. There are structured network, unstructured network, there are server services. This is the architectures we will face, we are facing in the Internet of Things. And what are we doing is that matching, in our work, in our deliverable, what we're doing is that matching views and perspectives. Now, I don't enter, we have a beautiful deliverable just out, 1.3 about architecture, which is published since middle of July, so it's only 1.5 months old. And basically, what in it is which design choice impacts what. It has an impact, for instance, if you have a service organization with mandatory security, has an impact on trust, security, and privacy, of course. It can be positive or negative. Yes, for instance, no input about performance, and so on and so forth. So the idea is that at the end, to build these matrices and tables, so that every single choice that you make, every single requirement that you have for your specific architecture, can be mapped and see which field exactly is impacting, okay, in your totally heterogeneous field. So then you can have some choices, for instance, which security model you want to use, according to what are the specific requirements and according to what is available at the time on the market. Let's take the communication model, for instance. If you take the standard internet one, it's very easy. Network gateway, internet gateway, network. Very easy. We have Internet of Things. We have constrained and unconstrained network. We have RFID tags, which can talk maybe a few centimeters, maybe 2 meters. We have sensors. We have actuators. I mean, we have, if I have a sensor here, for instance, for the temperature of this room, I'm not expecting to run soap on that. It's probably able to tell me there are 22 degrees and that's all. So there is some proper EDIFACT or whichever communication protocol is using, but it's probably very basic. And the constrained network enters the IoT model, which means that, unfortunately, we will probably need gateways at some point. I know IPSO people very well. I know they are pushing IPv6 everywhere. Personally, I don't believe that IPv6 will be in every single object. And there are two classes of objects. Every time we speak, I mean, they don't have any answer. One is the stateless ones. Obviously, if you have a stateless object, it cannot, the only part I can have from my IP protocol is a payload of one packet. And because IP protocol is best effort, I will never know if it reached the destination. If I have a temperature sensor here, a very cheap one, it can just tell me there are 22 degrees. It can wake up every 15 seconds, it just sends the temperature and fall asleep again.